Hello everybody, and welcome to the beginning of Chapter 9. We are looking at page 68 of the workbook, and the subject of this chapter is normal subgroups and factor groups. And just to give you a little bit of background on this, a factor group is a special type of a group that has cosets as the elements of the group. I think the best way just to introduce ourselves to this topic is to start off with an example. We're going to look at example 1 together here, and this is going to be kind of an exploration, an opportunity to kind of get to know factor groups here. So let's read this example together. So let D4 denote the group of symmetries of the square, and consider the subgroups K1 equals R0 and R180, and K2 equals R0 and H. Okay, and you'll notice that we've got a Cayley table for D4 sitting here that might help us with some of our calculations. Okay, and what I'd like to do in this video is to do kind of half of part A here. It asks us to calculate the left and the right cosets of K1, the first of those two subgroups in D4. We're just going to calculate the left cosets in this video. Okay, now before we do this, let's maybe think a little bit. It's been a couple of chapters maybe since we talked about cosets. So how many cosets are there going to be? How many left cosets would there be of K1 in D4? Well, we know that D4 has 8 elements, and K1 has 2 elements, so the number of cosets should be 8 over 2 is 4. That's the number of cosets that we would expect here. All right, and so we'll start with the nicest element of all in D4. How about the identity, R0? And think about what we would get if we multiplied that by K1. Okay, well, if we take the identity element and multiply it by both of the elements in K1, we're just going to get the set K1 over again. Okay, so our first coset just looks like the 2-element set that contains R0 and R180. Okay, and to get our next coset, we want to choose an element of D4 that's not in this first coset. Okay, so how about R90? Okay, we'll take that and multiply it by K1. All right, and let's see, that means that we're going to be taking R90 and multiplying it first by R0 and then by R180. If we do that, we're going to get R90, okay, and then R90 times R180 is going to give us a 270-degree rotation, so there's our second coset. Okay, and so now, to get the third coset, we want to choose an element that's in neither of those first two cosets. We've kind of taken care of all of the rotations, so how about H? Okay, and now we're going to take H, and we're going to multiply it by R0 and R180. Okay, well, H times R0 is going to be H, obviously. What about H times R180? There we might have to look at our handy-dandy Cayley table here. So let's see, here's H and here's R180, and our Cayley table tells us that we're going to get V if we do that. Okay, so we've got 3 out of our 4 cosets. And the last one, let's see, choose an element that hasn't appeared in any of our 3 cosets. How about D? I'm hoping that maybe you can tell me what that last coset is going to be without even doing any calculations. Remember how we said that cosets have to partition a group? Okay, well that means that this last coset has got to be the 2 elements that we don't have yet, D and D prime. Okay, and so notice we've got a complete partition of D4, and we have just calculated the left cosets here. Okay, so at this point, here's what I'd like you to do. So go ahead and stop this video, and I'd like you to calculate the right cosets of K1 and D4, see what you get, and then maybe think a little bit about this question. What do you notice before you go on to the next video?